Welcome to the Pharmacy Inspection Podcast, powered by lyceumce.com, where we discuss topics related to both sterile and non-sterile compounding pharmacy in an effort to promote compliance and increase quality. Please welcome your hosts, Brian Prince and Seth DePasquale.
Hi, this is Seth DePasquale, board-certified sterile compounding pharmacist, and it's Friday, and that means we look at another 43 to try to help us understand and learn about compliance within sterile compounding. So let's jump right in. The learning objectives for today's 43, by the end of this, you should be able to explain how action levels are used to maintain a controlled environment, define 5 steps to DMAIC, explain the 5 whys technique for finding a root cause, and discuss the proper documentation for documenting a deviation. In this week's 43, we're going to talk about investigating microbial contaminations inside the clean room to find out possible sources and remediate the issue. We're also going to talk about writing up that investigation and the resulting corrective action, preventive action, or CAPA as a result. In this 43, the firm failed to adequately evaluate and test for possible causes to the contaminations. The first observation is, you did not make adequate product evaluation and take remedial steps where actionable microbial contamination was found to be present in an area adjacent to the ISO 5 classified aseptic processing area during aseptic production. Equipment within or in close proximity to the ISO 5 area could compromise the area in the ISO 5 area. Specifically, you keep in the ISO 7 buffer room. During the cleanroom recertification activity on 1/25/19, third-party cleanroom certification business identified an airborne viable environmental monitoring out of specification of 15 CFUs at location corresponding to the PIC identified a preventative action of not permitting the operation of this piece of equipment during cleanroom recertification activities and a corrective action of cleaning and resampling the environment of the classified areas. You have failed to investigate and eliminate the identified potential source of the air contamination in the ISO 7 buffer room, background to the ISO 5 laminar airflow hood. So in this observation, the FDA notes that the PIC identified one possible cause of the contamination, but failed to test that theory. They didn't retest the air in that area of the buffer room to see whether or not it was in fact the cause. It's difficult for us to perform a full investigation with the limited information we have from the 43 alone, but we do know that there were 15 CFU found at a particular location, which exceeds the action level for the ISO 7 class buffer room. Here are the action levels for viable airborne particle air sampling found in USP 797. ISO class 5, if you have greater than 1, you need to take action. ISO class 7 if you have greater than 10, and ISO class 8 if you have greater than 100. USP doesn't give too much direction on how to go about doing an investigation either. Here's what they say. If levels measured during viable air sampling exceed the levels in Table 5, an attempt must be made to identify any microorganisms recovered to the genus level with the assistance of a microbiologist. This is in USP 797 Data, Evaluation, and Action Levels. 797 only gives us possible corrective actions for us to take once we've figured out the source of the contamination. If levels measured during the viable air monitoring program exceed the levels in Table 5 for the ISO classification levels of the area sampled, the cause must be investigated and corrective action must be taken. Data collection in response to corrective actions must be reviewed to confirm that the actions taken have been effective. The corrective action plan must be dependent on the CFU count and the microorganisms recovered. Some examples of corrective action include process or facility improvements, personnel training, cleaning and disinfecting, or HEPA filter replacement and/or repair. There's a system I like to use to investigate issues like this, and it's borrowed from Six Sigma called DMAIC. It's an acronym DMAIC, and it's an acronym for Define, Measure, Analyze, Improve, and Control. In the define step, you're going to do just that. Define the problem. You'll want to document how the problem was identified and create a problem statement that describes the issue in detail and what needs to occur for the problem to be considered remediated. In this 483, we define the problem as being contamination of 15 CFUs, or colony forming units, were found to be in the ISO 7 buffer room in one particular location. In the measure phase, you're going to set up a way to collect data that will help you identify the root cause of the problem. In this case, the data measurement collection tool we would be using would be continuous air monitoring. The key with viable air sampling is that you identify the colony to the genus level at least. This will give the origin of the microorganisms to help you narrow down where they may be coming from. But there could also be measurements you may want to take once you've properly analyzed the problem. The next phase, analyze. To analyze the problem, there's a few tools that you can use. One is called the 5 whys. This is simply asking the question why 5 times to get the ultimate root cause of the issue. Why did this contamination occur? There was equipment in the room that was running that didn't need to be turned on. Why was this the cause of the contamination? The equipment has a fan that unnecessarily disturbs the airflow. Why does it disturb airflow during compounding operations? It doesn't need to be turned on. Why doesn't it need to be turned on? It's not necessary for compounding. Why is the equipment running then? This piece of equipment will be turned off during the compounding operations. But I wouldn't just stop here. This gets down to one possible root cause, but when it comes to contamination, there are up to 6 possible causes. For this, I would fill out what's called a fishbone or Ishikawa diagram. This is where the firm didn't go far enough and investigate the issue. As you can see, there's quite a number of other factors that can contribute to a contamination, and finding out the root cause is really important. Unfortunately, the 483 didn't detail whether or not the 15 CFU were identified, so this makes the investigation nearly impossible. Remember, without knowing at least the genus of the microorganisms found, there's no way to tell where they came from: people, materials, equipment, etc. In the improve phase, you'll want to test your possible causes of contamination. If you've determined it's equipment, maybe HEPA filters in your SEC need to be checked or changed. If it's people, perhaps the gowning procedures aren't sufficient for lowering the shedding of particles from your operators. Are materials being wiped off and disinfected before they're being brought into the clean room? Again, all these possible causes would be identified by the fishbone diagram. In the control phase, you've now narrowed down that it was a number of factors that contributed to the contamination. Let's just say for this case, we found that materials and equipment weren't being wiped off and disinfected prior to entry into the clean room. Also, let's say that operators needed to change their procedure for gowning, using more protective covering so that no skin is exposed while in the clean room. You then need to measure each of these solutions in some way to show that the root cause identified were in fact the issue, and the clean room is now under a state of control. First and foremost, you use viable air sampling, at the very least, testing that one location that had 15 CFU. If any CFUs are detected, then identify them to see what might still be causing the contamination. Next, you can ensure everyone is properly wiping off materials prior to the entry into the clean room using a checklist for clean room entry. Also, maybe you'd want to sample the operator's fingertips and thumbs, as well as parts of their gown post-compounding prior to them disinfecting the gloves and at the end of the procedure, to ensure that the operator is using proper aseptic technique, not contaminating their gowns, and using the proper behavior when inside the clean room. The results are in each of the new policies and procedures you've implemented worked. There have been 0 CFUs detected in that location for several weeks in a row now. However, you're only halfway done. You need to document all of this information in the form of a corrective action, preventative action documentation form. Depending on where you look, you may see that there are 8 or 10 phases to a corrective action, preventative action process. In the CAPA, you're going to use all the data you collected from DMAIC to document how you remediated the deviation and how you're going to check the effectiveness of the solutions. I've made a simple DMAIC worksheet for people to fill out along with and implement solutions to test for possible causes to a contamination. But DMAIC can be used for any number of problems. When you have a deviation of any kind, I suggest going through the DMAIC process to identify the root causes of the problem, test possible solutions, implement the ultimate solution, and continued monitoring to ensure control over the issue. I've also included a corrective action, preventative action form for download, which will allow you to officially document the deviation, how it was remediated, and what policies, procedures, and training results from the investigation and analysis. All these sheets are available for download on the blog under this post. This is the 483 number 4, Investigations in CAPA. And if you have any other questions, please feel free to reach out to me. I'm always happy to answer questions at seth@lycmce.com. Until next Friday, thank you so much for listening, and we'll talk to you soon. Keep raising the bar.
The Pharmacy Inspection Podcast is powered by lycmce.com, where you can find engaging video-based continuing education programs, as well as a social community for pharmacists and technicians. Join one of the discussion groups or forums and post your questions to the group. Lyceum CE, where fun CE gets done.